Section 6.1, ratios, proportions, and geometric means. So we are going to work on simplifying ratios and solving proportions, and then we're going to talk a little bit about this geometric mean of two numbers, which actually just is a ratio that's set up into a proportion. So here is some background information. These are things that you're probably pretty familiar with. If A and B are two numbers or quantities and B cannot equal 0, then the ratio of A to B is A over B. So a lot of times we write these ratios as a fraction. So you can write it as a fraction, or you can write it as A to B with the words. You can also use a colon. So there are three ways to write a ratio. And the ratio really just compares two quantities. And the quantities do not have to be the same. We do ratios all the time when you look at your test score. If you got 20 out of 30 on your test, that's a ratio. That's the number of questions you got correct compared to the total number. And we always simplify those ratios when we're talking about it. I mean, our test score, I know we usually get a percentage, but we're going to simplify the ratio into lowest terms rather than giving the decimal or percent is normally what we're going to be doing. So you always have to make sure that your ratios are simplified, but also you have to sometimes convert your ratios. And there is some, if you're not very familiar with converting units, like how many feet are in a yard and things like that, you can take a look on these pages in your textbook right there, and it gives you some conversions. Of course, you can always look it up in Google or internet, whatever. So if your ratios are the same, whenever you're going to simplify it, they always have to be in the same unit. We can write a ratio without being in the same unit, but when we simplify it, it has to be in the same unit. So in this first example, the pounds cancel out because we're in the same unit. We just get a ratio of 1 to 12. That would be the simplified ratio. When we look at the next example, we can write this ratio. I prefer to usually write them as a fraction. So 10 feet compared to 3 yards. That's our ratio. Well, they're not the same unit, so the units don't cancel. Well, this is a pretty easy one because most people know that there are 3 feet in 1 yard. So 3 yards would be 9 feet. And so if you know that, you can just change the units so that they're the same. So 10 feet to 9 feet. Okay, now these units cancel out just like they did over here. And so now we have the ratio is 10 to 9. That is our ratio. Now, in science, I think in sophomore or junior year, you do something called dimensional analysis. So another thing that we can do for this is we can take our ratio of 10 feet to 3 yards, and we can actually multiply it by a unit conversion. So we already said down here that we knew there were 3 feet in 1 yard. So we're going to put the 3 feet down here and the 1 yard up here, because now our units, because we're multiplying versus just what they're equal to, we can cross cancel these units diagonally. And so then that gives us a ratio of 10 to 9. So we still get the same ratio either way we do it. So it just depends on your preference, but I wanted to at least introduce you to that dimensional analysis piece where you multiply by 1 yard and 3 feet are the same thing. So you're really just multiplying by a value of 1. Some people are less familiar with the metric system. So you can look for those conversions on the pages 886 and 921, or look it up on the internet, but I'm going to write this. Again, I like to write it as a fraction. So 1,600 meters compared to 5 kilometers, not the same unit. Okay, but again, I know that 1 kilometer equals 1,000 meters. So what I'm going to do is I know that 5 kilometers then would be 5,000 meters. And this is kind of intuitive and pretty simple. So now I have the same unit, so I can cancel those units off, but then I also need to reduce. Well, I can certainly divide by 100 and get rid of those 2 zeros, and what that leaves me with is 16 over 50. Again, that could be reduced even more by dividing by 2, and so that equals 8 over 25. So that is our reduced and simplified ratio. Again, if you want to go the dimensional analysis route, you would take the 1600 meters compared to 5 kilometers, and you'd multiply by this conversion unit that we have right here, and we do the units diagonally. So 1 kilometer is equal to 1,000 meters. And then again, we can cross cancel our units, and we end up with the same 1600 over 5,000, which we know would simplify to this. So that's one of the pieces we're going to do. We're also going to find some missing pieces when we're given a ratio. So this says, find the ratio of a side length in ABC, triangle ABC, to a side length in triangle DEF. Well, the ratio of the side lengths of side AB would compare to DE, so I would write 2 centimeters to 4 centimeters. So now I'm just setting it up first. Units cancel out here, and so what I have is just 1 to 2. That is my simplified ratio. In the second example, again, we're going AB. Notice we want AB right here, the triangle AB, to DEF, so we should list that one first. So it's going to be 18 inches compared to 2 feet. Again, we don't have the same units. So I know that there are 12 inches equals 1 foot. So 2 feet would be 24 inches. Just intuitively. Again, if you don't know that, you could use dimensional analysis to solve this. But again, when I reduce my ratio, it becomes 3 over 4. All right, let's try some more examples. Now this gets a little interesting, but if I can try to walk you through intuitively what's going on, I think this will help for the next several examples. It says the perimeter and the ratio of length to width of a rectangle are given. So you're given the perimeter is 50 and the length to width ratio reduced is 3 to 2. So what does that really mean? Well, here's your rectangle. You know the perimeter is 50 inches. And you know one of the sides is 3 and the other is 2. So the length to width ratio is 3 to 2 when you reduce. Well, obviously the perimeter of a rectangle with a side 3 and 2 is not going to have a perimeter of 50. This right now has a perimeter of 12. So if you just look at something kind of simple, what if the perimeter was 30 and 20? Or what if the sides were 30 and 20? Well, that would reduce 30 to 20 would still reduce to 3 over 2. But that does not give us a perimeter. That gives us a perimeter of 30, 40, 50. That gives us a perimeter of 100. Now, by process of elimination, you can probably go, oh, we just got to cut those in half. And you're right. But what we do when it's not so simple to see is, what we do is we set this up and we say, well, in this case, I took 3 times 10 to get 30. And I took 2 times 10 to get 20. So what we're looking for is, what do we multiply this 3 by? And it has to be multiplied by the same number in order to get that same ratio. So 3x compared to 2x would still give me the ratio of 3 to 2 because those x's would cancel out since they have the same value. So that's what I'm really doing. I'm looking at 3 times some number, 2 times some number. So again, if I just multiplied that by 2, that would give me 3 times 2, a length of 6 and 4, but that doesn't give me a perimeter of 50. So you could guess and check your way through. But instead what we do is we go, we know that it has to be 3 times some number and 2 times some number for the length and the width. And then it has to give me a perimeter of 50. So we know that our perimeter is equal to 2 times our length plus 2 times our width. So we take and set 50 equal to, I'm going to move this over a little bit, 2 times our length, which is 3x, plus 2 times our width, which is 2x, and we solve. So this is 6x and 4x equals 50. So this gives me 10x equals 50. So x equals 5. So 5 is your multiplier. So then what that means is this is 2 times 5, or going to be equal to 10, and this is going to be 3 times 5, which is equal to 15. So my length is equal to 15, and my width is equal to 10. So that's how we use this with geometry, the ratios. And let's try another example. The measures of the angles of a triangle are an extended ratio given. Find the measures of the angles of the triangle. So this is a little bit different because we actually have not just two or one ratio, but it's with two numbers. We actually have three numbers. So let's see if I can draw a little bit better triangle. Okay, so we know that this angle right here plus this angle right here plus this angle right here have to add to 180 degrees. Well, if this angle measure is 2 degrees, and this angle measure is 3 degrees, and this angle measure is 4 degrees, that is not going to add up to 180. So we do the same thing. We say, okay, well, you can kind of think it through a little bit, and you can say, okay, we know it's not 2, 3, and 4. But what if it was then like 20 degrees, 30 degrees, and 40 degrees? Well, if you add those up, 20 plus 30 plus 40, that still gives you extended ratio correctly, but that gives you only 90 degrees. So again, process, this one's pretty simple. You go, oh, we must just have to double these. Well, again, they're not always going to have them to be exactly working out that nicely. So what we do is we say, okay, well, if this is 2 times some number, this one would have to be 3 times some number, and this would have to be 4 times some number, and those would have to add up to 180. So we take 2x plus 3x plus 4x and set it equal to 180. So we have 9x equals 180, so x equals 20. That's our multiplier. So that means our angle measures are 2 times 20, or 40 degrees, and we have 3 times 20, or 60 degrees, and then we have 4 times 20, which would make this 80 degrees. And so now we have 180 total. Now, this is the same exact thing we just did with the angles. The 3 candidates running for an office in a local election, and there's a total number of 12,936 votes. Well, when all the votes are counted up and cast and separated for the 3 candidates, you have this extended ratio of 3 to 4 to 5. We want to find the actual number of votes cast for each of the 3 candidates. So like, is it 3,000 to 4,000 to 5,000? Well, that adds up to 5, 9, 10, 11, that adds up to 12,000 votes. But now we got to separate the rest of the votes. So again, what we're going to do is that same process, and we're going to set up 3x plus 4x plus 5x. When we add those together, that has to equal 12,936 votes combined. So what you're going to need to do is find x and then plug it back in to see how many actual votes were cast for each candidate. So if we just solve this, pretty simple. we get x is equal to 1,078. So now we take 3 times 1,078 to give us 3,234 votes were cast for one candidate. And again, just plugging these numbers, 4,312 and 5,390. That's the total votes for each candidate. And let's just talk a little bit about when you have two ratios that are equal to each other, it's called a proportion. So a proportion is an equation that states two ratios are equal. Numbers B and C are called the means, and number A and D are called the extremes. Now, I'm not going to make you memorize which ones are the means and the extremes, but it does help in some future properties because we refer to the means and extremes. And this cross products property is very powerful. And what it says is, this is one of the properties of proportions. This is the one we're going to work on today. We have some other ones in the next section. So the cross product property says this: in a proportion, the product of the extremes equals the product of the means. So what that means is when you take the means and multiply them together and the extremes and you multiply them together, you get the same numbers. So you can see if we multiply 3 times 4 together, we get 12. And if we multiply 2 times 6 together, we also get 12. And you could do it for other fractions, other equivalent fractions. So 2/5, another fraction that's equal to 2/5 is just like 4/10. That's easy to understand. So now if you multiply the diagonals and you take 5 times 4, that's going to equal 2 times 10 because 20 equals 20. So let's work on solving some proportions. I know these are things you've done in the past, and I know a lot of you don't show any work for this. I understand that, but I am going to, simply for the fact of when we get to x's involved, it's not quite as easy. So when I multiply this together, 16 times 18, that's going to equal 12 times b. So now I just divide by 12, and that's going to give me b equals 24. And I know you guys just plug that in your calculator a lot of times. But notice down here, we have an x value. Here we have 2 x's. Here we also have 2 x's, so they do get a little more complicated. Now sometimes it works out and it's very simple. Like this first one would be 6 times x minus 3 equals 3 times 8. And a lot of times when students are doing this in their head, they'll go ahead and write down 6x, but then they'll write down, minus 3, when this is really minus 18, because you have to use the distributive property, equals 24. Now I'm going to get 6x is equal to, when I add 18 to each side, I get 42. So then x equals 7. So you can kind of see the process that we're using to solve this. Sometimes when you have more than one x in the problem, it can get more complicated. Sometimes it doesn't. In this case, we're going to multiply 24 times x minus 12 and set that equal to 8x. And again, we're using the distributive property. The difference is I'm going to have x's on each side, which is really not that big of a deal. This gives us 24x minus 288 equals 8x. Get my x's on one side, which is going to give me 16x. Get my number on the other side, which gives me 288. I could have switched it around the other way, but now x equals 18. This last one does get a little bit more complicated. It doesn't look any different, any harder, for sure. But what happens here is I'm going to get 10 times 3 is equal to x times x plus 1. So 30 is equal to x squared plus 1x. And now I can't just solve this for x. This is a quadratic. So what I'm going to need to do is use the quadratic formula or factoring. So I'm going to subtract 30 from each side so that I get x squared plus 1x minus 30 equals 0. And now I can actually factor this. This is an easy factoring one where you look for two numbers that multiply to negative 30 that add up to 1. So those numbers would be 6 and negative 5. So now using the zero product property, I'm going to take and find out when does x plus 6 equal to 0 and when is x minus 5 equal to 0. Those are my two answers. So x equals -6 and x equals 5. When you plug the negative in, sometimes it's not going to work depending on the geometry problem that you have, but those would be your answers or solutions for x. All right, we've got a couple more examples here to go through, and then we'll be done. So it says the ratio of two side lengths of the triangle is given. So it gives you that AB to AC is 15 to 8. So all I do is take AB over AC and then set that equal to 15 to 8. Well, what is AB? 60. What is AC? 3D plus 2. And I set that equal to 15 over 8. And now we're just going to cross multiply. And why don't you try that right now? And when you're done, you should get D equals 10. And I will work out the rest of this in the notes if you did not get the correct answer when you tried it. Okay, here's another example. It says, in a high school where the ratio of seniors to underclassmen is 1 to 5, there are 125 seniors. How many underclassmen are there? So we know that the seniors to underclassmen is 1 to 5. We know how many seniors there are. We're trying to find how many underclassmen there are. Whoops. Make sure I get this set up in the correct format. Seniors to underclassmen. I need to do seniors to underclassmen here. So what that gives me is 125 over x. Now, I could have set it underclassmen to seniors, but I have to make sure the other proportion is in the same format and the same order. So now I can cross multiply, and I simply get that the number of underclassmen is 625. All right. The last thing I'm going to talk about is geometric mean. This is not going to come up much right now, and it's fairly straightforward, but it does come up in the future as we work through other future sections. So the geometric mean of AB is really just the square root of AB. So this is the geometric mean. In this case, we're letting x represent it. So what the geometric mean does is it satisfies this proportion that A over X is equal to X over B. So when you would cross multiply this, what you would get is X squared equals AB. So then when you would solve this by taking the square root of each, what you would get, since squares and square roots undo each other, you get the geometric mean, x, is equal to the square root of a times b. Okay, remember a, b next to each other means a times b. So in this first example, the geometric mean of 7 and 12 is simply the square root of 7 times 12. So x, the geometric mean, is equal to the square root of 84. And if we put that in simplest radical form, the square root of 84 could be written as 4 times 21. And when we give each piece its own square root using the product property, what we get here is that x equals 2 square root of 21. That is your geometric mean. So you try the next example and see if you can get the geometric mean in simplest radical form. And if you solved this correctly, when you get to your final answer down here for the geometric mean, you would get 12 square root of 2. And again, if you did not get that answer, look back to the notes. I will work it out in the notes. That is the end of lesson 6.1.